Hi there. Welcome back to the formulaic approach. Today we are going to talk about numbers. This video is specifically for those of you that are taking A-level maths course. Alright, now we're going to begin with numbers, and we want to basically in this short video classify numbers. Okay, so numbers are primarily classified into two broad categories, which are the complex numbers. Okay, it has the symbol C with a dash like this. Then the second category is real numbers. Now actually the complex numbers are the real numbers are said to be subsets of the complex numbers, and I'll tell you why. Okay, so but generally speaking, there is one such classification I've seen where numbers are classified into complex and real. Okay, complex and real. So the complex number is such one that has the form a plus bi. Okay, now let me tell you the origin of this I. Okay, it's also a number. Now a plus bi, this a is the real part, the real number, or the real number part. Okay, then this b is also a real number, but b together with the I is called the imaginary part. But b is going to be a real number, the imaginary part, and I is the imaginary number itself. Now, what is the origin of imaginary number? More like, think of it as number that doesn't exist, okay? But it was a solution to a particular problem that mathematicians came across, which was the problem of trying to evaluate the square root of a negative number. Okay, so when we get to complex number, we're still going to deal with it under this course. Okay, we're going to deal with complex numbers. All right, so the square root of a negative number was impossible to evaluate. So for example, let me say the square root of minus, let me use a perfect square like 4. But you know that the square root of 4 is actually plus or minus 2. What does this mean? This means that I can say plus 2 times plus 2 will give me what? Plus times plus, plus 2 times 2, 4. Minus 2 times minus 2 is equal to plus 4, because minus times minus is plus, and 2 times 2 is 4. Alright? Now, so what that means is that, so what square root means is the square, what is the number that will multiply by itself to give me the number here. So here it is plus 2 or minus 2 that will multiply by itself to give me 4. But there is no number that will multiply by itself that will give me a negative 4. Okay? Now some students might think that minus 2 times plus 2 should work, because plus times minus is minus, 2 times 2 is 4. But this is not squared. Squared means the number by itself. Minus 2 is different from plus 2. Minus 2 on the number line is on this side. If this is 0, plus 2 is on this side. Okay, so they are different numbers entirely. All right. So now they came across this problem, the problem of finding the square root of a negative number. So what they did was this. Now I can split this expression into minus 1 times 4. This makes sense, right? Minus 1 times 4 is still minus 4. All of them in root, right? In roots, right? This becomes, I break this into two parts. I have square root of minus 1 times square root of 4. I hope this makes sense. Square root of minus 1, square root of 4. I know that the square root of 4 is 2. But minus 1, square root of minus 1 does not have a number, right? It does not have, is impossible, right? So we now call that I. So the answer to this question now becomes 2I. Does that make sense? Where I now represents what? The square root of minus 1. So if this is the case, then it also means that I I squared is going to give us what? Minus 1. I squared will give us minus 1. Why? Because if I square this, square will cancel root and then we'll have what? Minus 1. Okay, so that's just complex number for you. No further classification. But I already told you, because this complex number also has real numbers, real number portions, then we say that a real number is a subset of complex number. Does that make sense? Now, what about the real number? Real number is further classified into two broad groups. We have the rational numbers and the irrational number. Irrational number. Now the rational number has a symbol that looks like this, like Q, then double line. Okay. Then irrational number does not have a specific letter for denoting it or symbol. What we just do is, this is real number, right? Since this is real number is denoted by this. Then we say that real number minus Q, that is minus rational number. The remaining, when you subtract rational numbers from real number, then you get your irrational number. This thing set means minus, okay? Minus, that is, I remove all of the rational number from real numbers, then the remaining will what? Irrational numbers. All right, then my rational number is now the broadest classification. I mean, the one that is further divided again. This one stops there, okay? So this one is now further divided into what is called integers that we use a lot. It's also divided into fractions, okay? And it's also divided into, we have terminating, and we have recurring decimal. That's another group. Recurring. So we have terminating decimals and we have recurring decimals. Okay? So we have this group under rational number. The integers are now further divided into, so rational numbers are numbers that can be, we call real numbers that can be represented on the number line. Okay, now rational numbers now comprise of all of these numbers. Any number, a rational number is any number that can be presented in the form A over B. Okay, where A and B are members of the real number real number. Yes, they are members of the real number. And B rather, and B is not equal to 0. Do you know what that means? Since B is not equal to 0, then it means that B must be any other real number. I hope you understand what I mean. B should not be equal to 0, because if B is equal to 0, we'll have an indeterminate term. An indeterminate term means a term that does not have an answer. Okay? So what does that mean? It doesn't mean that that there is no answer at all. What happens is that I've proven this before in one of my videos where I showed you that it doesn't mean that it doesn't have an answer. It actually has multiple answers. Okay, so because of that, we say it is indeterminate or undefined. Okay, so for that reason, our B must not be equal to 0 here. So our rational numbers are a set of numbers that can be represented in the form of A over B, where B is not equal to 0, and A and B are subsets, members of the real number family. So we now have integers. Integers are represented with the symbol Z, okay? The symbol Z. And under integers, we have two more groups. One is the natural number with the symbol N, okay? N, and the whole numbers, the symbol W. All right. Now, what's the difference between natural number and whole number? Our natural numbers are also called our counting numbers. Natural numbers are the counting numbers. Counting numbers. Now, there was a question that was asked 1 year that is integer, is 0 an integer? The way it is being defined is that an integer is any positive or negative natural number. So for that reason, students think 0 should not be there. Actually, integer is any positive or negative natural number including 0. So 0 is also what? An integer. 0 is also an integer. Okay? Now, also one was asked that, or if you were asked, for example, that where will you classify infinity? So infinity, for example, is not a number. Infinity is not a number. All right. So we have fractions. Okay. In this case, we are talking about proper fractions like 2 over 3, or negative fractions like minus 2 over 3, or improper fraction that will have both whole parts and what proper parts, such as 2 over 1 over 2. These are all fractions. Then we now have terminating decimals, such as 0.25 from 1 over 4, 0.5 from 1 over 2, 0.6 from 3 over 5, like that. So those are terminating decimal. Why are they terminating? Because they have an end. They stop here. Okay, they are terminating, they stop, they can stop. But recurring decimals are decimals that you get from a number like 1 over 3. 1 over 3 is going to be a fraction, okay, but the recurring form of the decimal is 0.0.3333333333. It doesn't end, okay. Some repeats, okay. Some are repeating. For example, we have seen I think 1 over 6 or thereabout. There's one such fraction that will give you 0.67676767 like that. So that one is repeating. They are also called what? Recurring decimals. Whether it's repeating every 2 numbers, every 2 digits, or repeating every 3 digits, that is also what? Recurring decimals. Now, what are now irrational numbers? Irrational numbers are the ones that they are non-repeating. They are non-repeating. So the irrational numbers now, they are non-repeating or non-recurring, non-terminating either, non-terminating decimals. Yeah, decimals, pretty much decimals. Examples include all square root of numbers, of all prime numbers, square root of prime numbers, for example, e.g. root 2, root 3, root 5. They are going to what? They will be non-repeating, they will have non-repeating decimal parts. Okay? Constants like pi, for example. Okay, someone has asked me this question too before that, but pi is 22 over 7. So for which reason it should be a fraction, right? Under rational. But no, the best approximation for the value of pi is this fraction. That is why they normally give you 22 over 7, okay? It's not exactly equal. You can try it. Punch, if your calculator is a science calculator, punch pi equal to, you see you're going to get a number that looks like this, 3.1415 something. But if you punch this in your calculator, you get 3.142 something. Is that clear? So because if you approximate this, you get 3.142, which is the first 4 digits here. So it is the best approximate. That's why you are usually giving 22 over 7 as pi. They are not exactly equal. The value of pi is non-repeating and is non-terminating. Okay. Another example is your exponential. Exponential has the value of 2.7182 . Okay. So this guy is also non-repeating. The values are distinct. They are different. They are non-repeating. So they are called what? Irrational numbers. Irrational numbers. All right, so that will be it on classification of numbers. So but keep in mind that numbers are from complex number, so it goes like complex numbers. So I can create another chart that looks like it. Complex numbers, okay? So from complex numbers, you link to what? Real numbers. Then under real numbers, you now lead to what? Rational and irrational. Okay, then under this you now lead to all of this. Is that okay? All right, so that is it on classification of numbers. In the next video, we are going to consider other aspects. We're not going to deal with rational numbers, deal with indices, deal with irrational numbers rather, deal with indices, logarithm, indices. And but there will be the advanced questions I'll be solving, okay? So do well to subscribe to the channel. God bless you.